Good afternoon. This is the second part of testing in Dolby Vision. Today we will talk about an interesting point, namely the influence of TV brightness on Dolby Vision output. We know that when we output DV to the screen, the image is dynamically processed based on the RPU, either in the player or in the TV. I decided to show you what happens to the image if we compare TVs with different brightness. For example, TV with 770 nit, this is the standard OLED at the moment, analogous to LG C1 and C2. The second TV is the G3 analog with 1400 nit brightness. The third TV with 2500 nit brightness is the mini LED analog, and the last one with 5180 nit brightness. Where did I get these TVs from? I took the edit I have, a hybrid EDID from the Sony A1 and LG CX, and changed the maximum DV brightness in the EDID. I ended up with 4 edits. And I ran tests on 3 players. Shield TV Pro 2019 and Fire TV Cube 3rd, they will be representatives of modern media players that can DV, but can't handle FAL layer. And the third device, Oppo UDP-203 clone, it's an old MediaTek chip but it can fully handle FAL layer. For each of the players I made a capture for different variants of video with different EDID, and now we can compare the results. The first test is a test for RPU L1 and L2 trims that are used in DV movies. The first file is L2 trims 4 steps test, 881 nits. Here is its L1 graph. It has the following characteristics: max CLL 881 nits, max fall 75 nits. Mastering is done for MDL 1000 nit. You could say it's analogous to a regular PQ 1000 nit video, which are most of them nowadays. In this case, max CLL and max fall are constant, and the image change is made solely by L2 parameters, which are called trim. Here are its L2 parameters. Each time only one of the L2 trim parameters is changed. And the L2 value of 2048 means 0 deviation, when there is no impact on the image. Look at the graph, it will be more clear by them. The first test is on a TV with a peak brightness of 770 nit. As you understand, 881 nit is more than the maximum brightness of this TV, so the player has to do tone mapping to match the capabilities of the TV. This is the Cube graph with L1 installed, without using L2. This is the Oppo. And this is the Shield TV. The gray bar on the graph is 750 nit, to make it clearer. The Cube and Shield TV produced exactly 770 nit, and the Oppo a little less. Then L1 trim slope 1024. The image compressed and dropped in brightness to 300 nit. Oppo did about the same. The next option is L1 trim slope 2700. We see an increase in brightness and actually cropping of gradations. The image of the sun and its glow now has identical brightness. I will not show all variations of L2 parameters, I just showed that at a TV brightness of 770 nit the effect of L2 parameters on the image is great. We also see a defect of Shield TV called red push, more red color is added to the image. Next, connect TV with brightness 1400 nit. Here I will only show the option for Cube, because Oppo and Shield TV act similarly. This is Cube with L1 enabled only. If we compare with the output on the TV with 770 nit, we can see that the brighter TV allowed to output the full brightness that is prescribed in the file, 881 nit brightness. And then the interesting stuff starts. Look, it's L1 trim slope 1024. If we compare it with the graph for L1, we can see that the image has not changed. Then L1 trim slope 2700, again no reaction. Why this happened? Everything is simple, the TV has enough brightness to fully display all the brightness prescribed in the video file, and it does not need additional optimizations to fit the brightness and the range of the TV itself. Now the next file, a movie analog made with MDL 4000 nit. Here are its parameters, MaxFall 500 nit and its constant, MaxCLL 3161 nit. And here are its L2 parameters, the same as the previous file. Again, we start with a TV with a brightness of 770 nit. This is the L1 for the Cube. This is the Oppo. This is the Shield TV. Notice how differently the players performed. The Cube lowered the average brightness, but left a margin for the brightest part of the image, but the Oppo and Shield TV overestimated the overall brightness, but left very little margin for peak brightness. Next we add Trim Slope 1400, which reduces brightness. All three players reduced brightness. The Cube again shows almost half the brightness than the others. As you can understand, the Oppo and Shield TV in this case will give a brighter picture on average brightness, but the brightness of the snowy peaks will be less pronounced. The Cube player on the contrary reduced overall brightness, but the snowy mountain tops will be brighter relative to the rest of the picture. But if L2 trim slope is set to 2700, then Cube has raised the overall brightness, but the whole image remains normal, gradations are not lost, but Oppo and Shield TV had cropping, they overestimated the brightness, and many bright elements lost gradations. Then we turn on TV with 1387 nit brightness. Brightness increased significantly relative to TV with 770 nit. L2 trim works identically. Either underestimates brightness or overestimates. Next is the TV with 2500 nit. Brightness increased even higher. L2 trim works the same, the change in brightness from changing L2 trim is less compared to previous TV. The TV with 2500 nit is bright enough that it doesn't need to do much brightness trimming. Note the difference between the players is only in the average brightness. The peak brightness is the same and equal to the maximum peak brightness of the TV itself. And here is the TV with 5180 nit. As we can see, L1 is displayed with full brightness prescribed in the file 3161 nit, and there is no influence of L2 on the image. This is logical, because the peak brightness of the TV exceeds the peak brightness of the video file. But this is a theory, as we remember, it does not always correlate with reality. So now let's turn to real movies. I will not consider movies with MDL 1000 nit. Let's check only movies with an MDL of 4000 nit. The first movie, Back to the Future. It has a very interesting feature. If we look at L1, we see that MaxFall is 387 nit and MaxCLL 4000 nit. This is quite a bright mastering. You can see that L1 changes for each scene, but L2 parameters are prescribed for trim under 101,000 nit, and only for brightness reduction. And now the most interesting, this is a frame from the movie file itself. Pay attention to the maximum brightness, it is equal to about 1000 nit, and all because the HDR layer of this movie is made under 1000 nit, although MDL is specified as 4000. MaxCLL is 1280 nit, but MaxFall is 987. As we can see, MaxFall of HDR layer is higher, and in fact, when viewing in HDR format, average brightness should be higher. But MaxCLL is higher in DV, and significantly, if I open this video in DaVinci, I see the HDR version of the movie. That's why the maximum brightness is a bit higher than 1000 nits. Now let's look at the results for different TVs. This is Cube on a 750 nit TV. The brightness does not exceed 400 nit, very little. On this TV, the Oppo peaks up to 750 nit, as it should. Shield TV shows similarly with the Cube. Next is the TV with 1387 nit. This is the Cube. This is the Oppo. This is the Shield TV. What we see, the image version with Cube and Shield TV barely reaches 600 nit and Oppo 1400 nit. Then the TV with 2500 nit, Cube and Shield TV reached 750 nit brightness. Oppo was giving almost 2500 nit already. And on TV with 5180 nit, Shield TV gave out brightness like HDR layer, slightly above 1000 nit, while Oppo showed a peak at 4000 nit. Why such a big difference? Even on a fairly bright TV with 2500 nit, the Dolby Vision version of the movie when played with the Fire TV Cube and Shield TV will only output 750 nit, 3 times less than the Oppo. What is the catch? I think many have already guessed. It's all about the FEL layer and the ability of the Oppo player to use it in processing. The thing is that players that do not know how to process EL layer from FAL disks will recalculate RPU parameters for the BL layer of the movie, and it in this movie is equal to 1000 nit and is strongly underestimated in brightness MXCLL relative to DVE. And it turns out that even having the brightest TV with 5180 nit, you won't be able to get the highest possible brightness if you watch HDR or DV version of this movie on a player that can't process FEL layer. But Oppo will be able to show much higher brightness of special effects in this movie, because in this movie they are mostly prescribed through L1 parameters, which are not an HDR version of the movie. And another bright movie. This is the Meg. Here's the L1 snippet I used. Mastering for MDL 4000 nit, Maxcal 3900, and MaxFall 841, bright mastering. And this is the HDR layer, MaxFall brightness average even higher than DV, MaxCLL also HDR has higher than DV, 4700 versus 3900 nit. Let's get started. Here's the snippet I tested on, peaks go up to 4000 nit. The first graphs are for a TV with a peak brightness of 750 nit. The Cube produced 750 nit, leaving the sun much brighter than the overall brightness of the rest of the elements. But the Oppo and Shield TV again decided that overall brightness was more important than the brightness of the sun. Next up is the 1387 nit TV. The situation is different compared to the movie Back to the Future. In this movie HDR layer is prescribed with full brightness, because this movie contains ML, not FAL version of the layer. So in this movie on any player, you will get full brightness information. And we can see that the Cube produced 1400 nit. Oppo and Shield TV also is on the darker TV sacrificed peak brightness in favor of average brightness. Next is the TV with 2500 nit. The situation has not changed, tone mapping is still used, because the fragment is very bright, but the difference in average brightness between the players is not so big, only 100 nit. And the last fragment on the TV with 5180 nit. Oppo and Shield TV produced even brighter average image than prescribed in HDR. Again, we see a defect with the red channel in Shield TV. What conclusions can be drawn from this part of the test? First, video with MDL 1000 nit will look similar to the HDR version on any TV which brightness exceeds the maximum prescribed in the movie. For example, LG G3 should output such movies without tone mapping with similar brightness as the HDR version of the movie. Less bright TVs with 600 to 800 nit will use tone mapping on such video. Second, brighter than the conditional LG G3 TV will not give an improvement when watching video with MDL 1000 nit. The image will be identical in brightness, of course, if you watch correctly, not trying to use, for example, DV bright mode. Their brighter TV will give additional brightness, but it will not be the way it was originally recorded. Third conclusion, movies with MDL 4000 nit that have a lot of bright scenes will benefit from a brighter TV. Some movies with a large FAL layer will look much darker on a media player that can't handle the FAL layer. So if you watch such movies, and there are quite a few of them, it makes sense to watch such videos on a player that can handle the FAL layer. And lastly, the brighter your TV is, the less difference there will be between HDR and DV, especially if the movie uses MEL layer for DV. Further player comparison tests I will do on EDID with 750 nit and in a few tests on EDID with 1387 nit. I think we'll call it a day. Goodbye, thanks for watching, subscribe, like it, and see you soon.